Hello, we are Group 5. Our topic is high frequency stock trading system. I'm Sun Shixuan. My metric number is A19947.
Okay, hello, doctor. My name is Lin Yang, and my metric number is A184458.
Hello, doctor. My name is Zhu Zhentao, and my medical number is A206174.
Hello, doctor. My name is Yang Chang. My next number is A214088.
This is our group work division. Um, I prepared the PowerPoint slides and read the poster content.
Okay, I designed the poster's layout and visual style.
I had collect related information and have checked the posted content.
I have to organize the presentation script and check the final format.
We will be talking about building a high frequency stock trading system. We will look at how different ways of writing code, which we call programming diagrams, can be used for this system. Let us start by looking at the looking at the big picture. Please imagine this situation with me. The financial market moves very faster. Prices go up and down in the blink of air. In this fast moving world, even a tiny delay of one single millisecond is a huge problem. Being late by just 1 millisecond can mean losing millions of dollars. This is the exact problem we are trying to solve today. A big environment company wants to build a new system. Now, what does this system really need to do? The main goals are actually very simple to understand. First, the system must look at the market data right as it happens. It needs to read this data and find hidden patterns, and it must do all of this in just a few milliseconds. The system must follow trading rules to buy and sell. It needs to make those traders in less than 1 minute or even faster. So to put it simple, we need to make the waiting time as short as possible. Why? Because the faster we are, the more money the company can make. Next page. However, building this system is a very hard job. We have three big problems to fix. The system needs to handle a huge amount of data every single second. The system must buy and sell with almost zero delay. The system must be very strong. It cannot crash or fail, even when the market is going crazy. To solve those big problems, we looked at two different ways to write code to write code. First, we chose the imperative way, and we will use the C++ language as an example. Second, we chose the actor model way, and we will use the Erlang language to show this. We will compare those two choices today. Now I will pass the time to my partner. My partner will explain these details to you step by step. Thank you.
Okay, thank you. Now I will talk about C++ and why it is useful in the high-frequency trend system. In this system, speed is very important. The system must read the market data, check the price, and make decisions and send the orders very quickly. Even a small delay can cause a lot change in the market. For these reasons, C++ is a strong choice. C++ allows programmers to control the program more directly. It is close to hardware, so it can run very fast when the code is written well. C++ supports improved programming. This means the programmers write clear steps for the computers to follow. This style is simple and direct, so it is good for the fast executions. C++ also supports object-oriented programming. In the trending system, we can use the objectives to organize the market, date, trending orders, and trending structures. This makes the systems clearly and easily to manage. Another important advantage is memory controls. In C++, programmers can decide when to create memories and when to freeze memories. C++ doesn't depend on the automatic garbage connections. This is useful because garbage connections may pause the program, and any pause can be dangerous in high-frequency trading. C++ can also use fast data structures such as kernel-friendly structures and local free queues. They can reduce waiting times and help data move faster inside the systems. Because of these advantages, C++ is suitable for the most time-sensitive parts of the system, such as market data processing, structures conclusions, and order execution. However, C++ also has weakness. It is harder to write and harder to debug. If the programmer makes mistakes, memory leaks or pointer errors may happen. These programs can make the systems unstable. Also, C++ does not automatically provide strong fault tolerance. The developers must design error handlings, logins, and recover by themselves. If one part has a serious error, it may affect the whole system. So our conclusion is that C++ is excellent for speed, but it's not enough for the system's stability. To solve the stability problems, we need another paradigm. Next, my group members will introduce ELANs and the actors models, which are better for the fault tolerance and stable distributed control.
Okay, thank you, Li Yingyang. And now I will explain the extreme stability for airline. In a high-frequency stored trending system, speed is very important, but stability is also very important. That is because the system needs to run all the time. If the system stalls for even a short time, it may cause the final loss. For C++, is the biggest advantage is the speed. C++ can run very fast, so it's suitable for the trending execution part. For example, when the system finds a good transition change, and the C++ can help the system place the order very quickly. But C++ also has some risk. For example, a memory problem may happen if the programmer is not managed carefully. One small area may affect the wheel system. Airline is the different. Airline focus more stability and the fault tolerance. Airline uses the actor model in the model. Each actor works like a small independent worker, and each actor has its own job. They do not share memory directly. Instead, they send message to each other, and this makes the system safe and easier to control. If one actor has the problem, it not easily weaken the wheel system. Other actor can still continue working, and so airline is very useful for the management part for the trading system. It can help the system stay stable even with some small area happen. This is what say C++ is better for speed, and while the airline is the better for stability. Next page. And the side is about how airline handling system futures. And the most important idea in airline is the called let it crash. At first, the sentence the may sound stranger, but does the no mean airline ignore the problem? It means that when the small pressure as one area, the process can store safe. Then the system can restart again. That is the better the later will the system become struck or crash. And airline also use a supervisor trees and supervisor tree like a management in the system. If the watch the other worker process, if one worker process crash, the supervisor can notice. Then the supervisor can restart the process automatically. For example, is the trending system. One process may be used many market data. If the pressure suddenly fails, the supervisor can restart it quickly. The wheel system does the no need to stop, and that is very important for high frequency trading because the system must keep running and respond very fast. So airline is the strongest for tolerance. It can help the system recover for problems. In our final idea, we think the hardware system is the better. C++ can be used for the fast charting part, and airline can be used for system control and for the recovery. But using both the language together, the system can be fast and also stable. Okay, next person.
Okay, thank you, Zhu Zhentao. Oh, now let's compare C++ and the iLine for our HFT systems. C++ follows the imperative paradigm and has much lower latency. This is extremely important for high frequency trading. HFT requires replied response, so this active makes C++ a top choice for time-sensitive tasks. Unlike use the actor model, it works better in flight itineraries and the system stability. Even even when unexpected error happens, the system can keep running without big interruption. To sum up, C++ delivers speed with the airline ensure suitables. This is the key trade-off we found. Okay, next page. Now I will talk about how we use the AI tools through this project. We use ChatGPT to do surveys and build our former work. Still, we checked all information with the official documentation and the courses materials. AI first suggests patient for coding. However, its GIL makes it too low for low necessary tasks. So we finally choose C++ for core work. We compared different languages carefully to pick the most suitable one for our HFT requirements. We learned that AI is a great helper, but human verification is always necessary. It can improve our work in efficient, but we must always confirm every details by ourselves. Okay, next page. Now let's move to our conclusions. No signing programming paradigm can solve all problems in any HFT system. C++ runs fast, and the airline is highly reliable. Therefore, we use the hybrid academic tree C++ deals with trained execution, and the airline manages systems, service, and follow recover. This decision perfectly balances performance and reliability. It combines the strengths of both languages to meet all the needs of our high-frequency trading systems. Next page. Let's look at our references. This presentation is based on our academic poster. We refer to Princeton books, course guidance, and use the AI for search report support. Other scenarios and keys we vision come from this Quibe recipients. Okay, next. Okay, thank you for listening to our presentation.